Let's say Ethernet. Now, we're looking at Ethernet and csmacd. Now, where do we use these? Now, these are used when computers are communicating on what we call the LAN. LAN means local area network. Local area networks are networks where computers are connected using cables. Computers are connected using cables. So when computers are connected using cables, when they're working, they will use what we call the Ethernet technology. They will use the Ethernet technology when they are working. They will use the Ethernet technology, or what we call the Ethernet protocol when they are working. Then they will also use what we call the csmacd principles when they are working. So all computers connected using cables must follow this. And this happens on the local area networks. Now, how does the Ethernet technology operate on the csma/cd? How does it operate? I don't know who J is. I want to remove you unless if you use proper names. J. That's why I'm removing you. I want proper names. Rename your Zoom and get back. Now, with the Ethernet technology, this is how it works. First of all, when computers are communicating, they'll all be connected to one central cable. So here we shall have computers, computer 1, computer 2, computer 3. They'll be connected to one central cable. This one here, this will be a central cable, and this will be referred to as what? A central medium. It will be referred to as a central medium. So they'll all be connected there to the central cable. That is one. Now, only one computer is allowed to communicate at a time. But how? When a computer is communicating, it will send information to the central cable. When it sends information to the central cable, that information will flow over the cable. As it's flowing over the cable, other computers will tap the cables. So we'll access the main cable and access the information to see if it belongs to them. For example, if computer 1 is communicating to computer 2, computer 1 will place the information onto the cable. Then the information will travel. As the information is traveling, it will have the IP address of the receiver or the computer supposed to receive, which is now the IP address of computer 2 in this case. Now, when computer 3, when the information is moving over the central cable, computer 3 will receive the information and check, am I the one supposed to receive it? Yes or no? If computer 3 is not the one supposed to receive it, to forward the message and put it back on the main cable. Then the second computer also will tap the cable, check the information. If it's the one supposed to receive it, it will get that information. Now, in this case, only one computer is allowed to communicate at a time. Only one. If computer 1 puts data here on the cable, computer 2 and computer 3 won't put data there. They will wait until when the data for computer 1 has been removed. So one computer is allowed to communicate on the network at a time. That's the second point. Now, when more than one computer or many computers try to communicate at the same time or at a go, for example, if computer 1 sends data and computer 3 sends data at the central cable, it means computer 1 and 3 are trying to use one network at the same time. That one causes what we call a collision. That causes what? A collision on the network. And in that case, what will happen? All the communication from the computers will be cancelled. So it means all the information they would have sent will be cancelled and the main cable will be free, or the network will be left free. Now, how do computers determine that a collision has occurred, and how do they avoid collisions? Now, they use what we call the csmacd principle. csmacd principle. What does it stand for? It stands for carrier sense, multiple access, and collision detection. Carrier sense, multiple access, and collision detection. How does it work? When a computer wants to communicate on the network, it will first check if there's no other computer communicating. In case there's another computer communicating, that computer will wait until when that communication is over and it tries again later. In case two computers or many computers more than one computer try to communicate at the same time, then the computer will be able to detect that the collision has occurred. When they detect that the collision has occurred, which means they're communicating yet already the other computer is communicating, then they will stop the communication. That's what collision detection means. So computers will be able to detect if a collision has occurred or not. Then carrier sense means computers will always try to check if the network is free or not. That is carrier sense, checking if the network is free or not. In case it's free, they will communicate. If not free, they will wait. Multiple access basically means the network can be used by more than one computer, though only one computer uses it at a time. So it's the principle they use. So by using csmacd, computers are able to detect that a collision has occurred, and because of carrier sense, they're able to avoid collisions because they will first check if the network is free or not. So this happens on the LAN networks, local area networks. Only one computer works at a time. And that is applied in what we call the bus topology and sometimes in the star topology. So that's what Ethernet means. So Ethernet basically is just a technology which is used by computers on the LAN to communicate. But when they're communicating, they use the csmacd principle to avoid collisions.